source transformation and source shifting, as well as problems based on source transformation and source shifting. And the first point, that is source conversion or source transformation. Source conversions or source transformations. Under this heading, we will first start with the first point: voltage source to current source transformation. Or conversion. Voltage source to current source conversion or voltage source to current source transformation. First, draw this figure. This is not a difficult point, already you have studied many times. Just I will write the similar things. Its equivalent conversion will be something like this. I will focus on the point which is difficult. This is A and B, this is A and B. Here, given source is the voltage source. We can convert the voltage source to the current source. And its direction will be same as the direction of the positive terminal, towards positive. Is it right? And its magnitude of this current source, will be V upon R. Is it right? This is V upon R. We will see through the examples. And whatever the resistance here we have in series, that will be in parallel. Is it right? Otherwise, if we are converting into the admittance, it is 1 upon R mho. It is something like this. It is 1 upon R mho. Actually, it is admittance. Whenever we are considering in the parallel, we are calling it as admittance. But we can put in the resistance form or in the admittance form. That depends on you. Again, I am considering it as R only. Is it right? This is voltage source to the current source conversion. Second point, that is B point, which is current source to the voltage source conversion. Current source to voltage source conversion or transformation. One and the same thing. It will be something like this. This is very same as something like this. Here is A, this is B, here is R, and this V will be equal to I into R, where I is this current and R is this resistance. We have to understand the two things. First is source transformation. I am talking about the source conversion or source transformation. The second point is source shifting. That we will, because while reducing the complicated network into the single source or single current source or voltage source, at that time we have to use the two techniques. One is the source conversion or source transformation, and other is the source shifting. This technique is a very popular, simple, known to you. Is it right? You have studied in the first year, I guess. Conversion of the voltage source to the current source. And I will not spare the much of the time on this. I will go to the next point, which is the source shifting, which is new to you. Now here, this is first point, this is second point. Source shifting. Source shifting. many times we need to use the source shifting kind of the technique, because the conversion of the voltage source to the current source is not possible in many cases. I will give one example here. Before going to this topic, I will just discuss few points. Suppose the given circuit diagram is something like this. If the given circuit diagram is something like this, here it is, and we want to calculate the current in this branch using source conversion. Is it right? So we have only one source, which is this. When we are able to convert the voltage source into the current source, only when this source has a series resistance. At that time we can convert this voltage source to the current source. But here, in this case, this voltage source don't have any resistance directly in series with the source. Is it right? Means one resistance is here, another is here, common point is here. In such cases, directly conversion of the voltage source to the current source or current to the voltage source is not possible. In such cases, we are using this technique which is known as source shifting. Is it right? First, we will complete the source shifting. We will make the circuit simple, and after that, we are applying the conversion formulas, and then we are reducing this network into the simple network, and then we are able to calculate its voltage and current in that particular case. असं काही special घडलं? Something? Because just your simple one nonsense thing, it creates the disturbance in my mind, and I will be diverted from the main focus to the other point. Now here in this case, such things are needed for source shifting. And the first point here, that is voltage source shifting. First point, voltage source shifting. Now here in this case, we will try to understand when we are able to shift the voltage source. First, draw this figure. Voltage source shifting. When we have the network of that category, in that particular case, we can use the source shifting. And it will be something like this. It's equivalent network. This is A, this is B. Here is R1, this is R2 again, and this V. This V can be connected in this branch as well as in the second branch, and both branches are the parallel, and this is nothing but voltage source shifting. This is the voltage source shifting. Similarly, we have the technique of the current source shifting. Current source shifting. This is I. This may be R1, R2, R3, R4, R5, and R6, whatever. Just we want to understand the concept of source shifting. It's equivalent, or I'm less bothered about this part of the network. Just like I have taken only this part of the network, only this much part. In the similar way, I'm least bothered about the remaining part of the network. Otherwise, you can draw only this much portion of the circuit. That is sufficient to you. Now in this case, how we are able to shift the network? Whenever we have the current source, something like this, that is nothing but current source shifting. Current source shifting. Its equivalent, I will draw only this part. I will not draw that particular part. Yes. Whenever there is branch in which the source is across both combinations, it can be splitted into the two branches, just like here. This is also I will be here, the same I will be here, but in place of showing across the complete combination, we have shown across the individual combination, and that kind of the approach of the shifting is known as the current source shifting. How to do it? When we will go through the examples, you are able to understand when we need to do the current source shifting and when we have to use the voltage source shifting. That kind of the approach we can use for the source shifting. Is it right? I discussed the 2 points. First is the source conversion, voltage source to the current source conversion. Second point, current source to the voltage source conversion. Second point which I have started is the source shifting. In this case, the first point is voltage source shifting. Second point is the current source shifting. And now we will discuss about third point, which is equivalent circuit of the sources. Third point, equivalent circuit of the sources. Equivalent circuit of the sources, because many times it will also help to find out the series and parallel combination of the sources. Here first I will consider this figure. What will be the equivalent figure of the sources which are connected in this fashion? What will be its equivalent figure? Here, its equivalent figure will be something like this. There is A and this is B. And what is the value of this source? V1 plus V2. Is it right? Yes or no? It is not like that. Whenever we have the sources, this is one and this is other. In this case, V1 plus V2 is applicable. Are you getting me? Or maybe depending on the polarity, if it is negative, positive, it will add or it will subtract. But in this case, this is V only. Whatever here we have, this V1 is equal to V2. Is it right? But one can say, if it is 4 volt and it is a 5 volt, then what you will write? Is it right? You might be thinking in the same. Yes? No. Whenever we have the two sources having the different potentials, it is always recommended that never connect such sources in the parallel, having the different values. We may connect, but I will go to the another figure. Because whenever we have the different sources of the different magnitudes, it will overload to other source and it will draw the maximum current from that source, and that another source will burn. And its concept is given in one of the book, that is very good book, that is Robert Boylston. Is a very good book, looking to be big, but its concepts are very, very simple than technical publication, TechMax publication or Nirali publication. You can go to the library and find the book Robert Boylston. It is very nice book. And they have given which circuit is invalid. And when we are connecting different sources in the parallel without any internal resistance, such sources cannot be connected. If we have connected, it will burn one of the sources. We can connect the two sources in a parallel in this fashion. That is allowed. This is one and this is the other. It is allowed. Because some voltage drop will be there, because the potential across the parallel element must be the same. What is the basic rule of the parallel circuit? Voltage across the parallel element must be same. But if we are connecting 4 here and 5 here, the voltage across the both branches may not be the same, and it will overload to one another. Means if we are doing this, it is invalid network, and the theorems or whatever the theory we are studying, it is not applicable to this, and this circuit may not be the stable circuit. One or the other hour it will damage. Is it right? We can connect something this fashion. If we have, this is 4 volt, this is 1000 volt, it is allowed, because the resistances are there, and the some drop will be here, other drop will be here, and finally the voltage across the both elements will be the same, and parallel circuit we will have the same potential across this. But whenever we have the two different sources, ideal sources with the different potentials cannot be connected in the parallel. Are you getting me? Now, this is the conversion, and V1 is equal to V2 is equal to V. Only then we can connect such kind of the arrangement, and its equivalent value will be this. That is one case. The B point. These are the basics. I am discussing about only the basics. Now here, this is B point. Whenever we have, this is one and this is other. A terminal, B terminal. Here is I1, this is I2. What will be the equivalent circuit of this? When we have the two parallel sources of the same magnitude, maybe V1 and V2, when V1 is equal to V2, we can replace by this. Whenever we have the two current sources in series, I1 is equal to I2, absolutely fine. Now here, in this case, this will be the I. And the two current sources we can connect in the series only when both have the same magnitude. Are you getting me? This is counterpart. Whenever parallel is this, what about the series? You are already aware of it. V1 plus V2 will be the series. For this, whenever both current sources are in parallel, what is the resultant current? I1 plus I2. You are aware of that. This, whenever current sources are in series, in that case, the resultant current source will be something like this. And in this case, the two current sources, in this case, whenever I1 is equal to I2, only then we can connect the two sources in the series. Otherwise, we cannot connect the current sources in series. Is it right? Now, the third point, which is the C. Now here, in this case, whenever we have something like this, this is I and this is V. What will be the equivalent of this? One is the current source, other is the voltage source connected in parallel. What will be the equivalent of these two? What will be the equivalent of these two? Any guesses? Its equivalent circuit will be something like this. This is A, this is B, and here is V. Why? I will discuss. Now here, before going to analysis of anything, we must aware about one thing. Now here, in the network analysis, for the sources especially, current and voltage, for the sources, we don't know the two things. We don't know the two things. Be careful. Here, if we have this voltage source, having its voltage is a 5 volt, we know its voltage, but we don't know the current flowing through the voltage source. Always. Kabhi bhi. We don't know one thing about the voltage source. We know its voltage, but we don't know the current flowing through the voltage source. We have to calculate indirectly. How? Suppose there is resistance of the 5. Now we can calculate the current flowing through the source. Is it right? Because directly the voltage of the voltage source is given, but we don't know the current flowing through the voltage source, that we have to calculate indirectly. Similarly, in case of the current source, this is I is the current, or 4 ampere is the current. In case of the current source, we know the current flowing through the current source, but we don't know the voltage across the current source. You might have been studied the mesh analysis in the first year, and in case of the mesh analysis, whenever there is a current source, we are not able to apply the KVL to that loop. Why? Because we don't know the voltage across current source directly, we have to calculate indirectly. Means if we have the another arrangement here, something like this, it may be the 5 ohm, we can calculate the voltage across 5 ohm, whatever here is there, same will appear across that. That kind of the approach we will use. Is it right? Now here come to this figure. When we are looking at this terminal, we are interested in the voltage. We don't know the voltage across this source, but whatever voltage source this voltage has, the same voltage will appear across this. That's why its equivalent will be something like this. Is it right? Similarly, the last point related to this category is this. Equivalent circuit of this. Here is the current source of I1 value or I, and here is the voltage source of some V voltage. Then what will be its equivalent circuit? Yes? Only current. Because here, if we are thinking about the voltage here, not possible. Because this voltage is known, but this voltage is not known. Then we can think about the current. Is it right? Whatever it may be here, voltage, because this is a constant current source delivering constant current independent of anything. That's why its equivalent figure will be something like this. Here is the current source of I value, here is A terminal and B terminal. And only these things are sufficient to solve any problem based on source shifting and source conversion. First two problems, I will go very slowly. If you have any difficulty related to any point, ask me there itself. And then I will increase the speed a little bit. And the first point related to this category, our first problem. Convert the following sources into single voltage source. Single voltage source between the terminals A and B. between the terminals A and B. This figure should be equivalent for the terminals A and B. We will start with simple and then I will go towards the complicated. This is 5. This is 5 again. This is 5 and it is of the 1 amperes. We want the single voltage source between the terminals A and B. You can start working on it. Convert it into the single source. How it is possible? Because we want the equivalent source between these two terminals. Now, either convert the current source to the voltage source or voltage source to the current source. When conversion is needed, I will discuss that. Whenever we want to reduce the circuit series wise, then better to have a circuit in voltage sources, because here is one resistance and here is another resistance, here is one source and here is another current source, this kind of the thing. In that case, what we have to use? This is A and suppose this is B. And here is this current source of 5 ampere something and this is 5 ohm something like this. In that case, we want to reduce the circuit in the series wise. Is it right? It's better to convert this current source to the voltage source, because resistances can be added in the series, voltages can be added in the series, and that will become simple. And whenever we want to reduce the circuit in parallel wise, then better to have the circuit in current source. That simple trick is sufficient for the source conversion and source shifting. Now, here is one branch. Is it right? This is one, this is the other. Now circuit is in the parallel. If I will convert this voltage source into the current source, it will come in parallel combination. We will find out the parallel value and sources will be added directly and we will get the final circuit in simple steps. Is it right? One rule is required whenever we want to reduce the series wise. In that case, sources must be in voltage sources, and when we want to reduce in parallel wise, in that case sources must be current sources. Now here, first we will convert, and first converting 5 volt voltage source into the current source. Converting 5 volt voltage source into the current source. Its figure will be something like this. 5 volt voltage source into the current source. Then figure will be something like this. Here is the figure. This is 1 ampere, this is 5 ohm. Is it right? And this will be the 5 ohm. And here will be the terminal A and this will be the terminal B. Any confusion? We have not modified this part. It is as it is here. Is it right? And we have converted this voltage source to the current source. Miss here, how is the equivalent current source? This is voltage source, its equivalent current source will be something like this. Here it is equivalent current source, which is this. And I have replaced this circuit here. That's it. Here is the 5 ohm. I copied that as it is. And now the value of this magnitude, its direction will be upward, because upward is the positive terminal is upward. And how much is the current? Which is 1 ampere. Is it right? 1 ampere is the current. Now, the sources are available in the parallel. We can put that source here, because in the parallel we can replace one branch by the other by keeping the similar things. Now here in this case, its equivalent circuit will be something like this. Here is A. Just I am doing the readjustment, nothing else. I am not applying any formula right now. Just I am doing the readjustment of this figure, which is not required at your level. You are the beginners, that's why I am drawing this. Otherwise, this figure is not required. This is 1 ampere. This is again 1 ampere. Here, this is 5 ohm. This is also 5 ohm. And this will be the B terminal. This figure is optional. Is it right? Now, how is the reduction? These two are parallel, these two are parallel. Whenever sources are parallel and those are the current sources, what is its equivalent value? Add up. Now here, its value will be something like this, which is the upward direction, which is 2 amperes. And parallel combination of these two will be here, which is 2.5 ohm. Here is the terminal A and this will be the terminal B. Is it right? Yes or no? 5 is parallel with the 5? 2.5. Because 5 into 5 divided by 5 plus 5. What is the parallel circuit? Rule of the parallel circuit. R1 into R2 divided by R1 plus R2. That's simple trick. Or 1 upon R is equal to 1 upon R1 plus 1 upon R2. Same thing. Is it right? आपको अगर छोटा भी difficulty है how to find out the parallel combination, then also please ask me, because at the time of understanding the first problem, your all doubts must be solved here itself. Then I can increase my speed from the next problem onwards. Is it right? Now here, are you followed this? Now here this, and finally we want to find out its equivalent voltage source, which will be something like this. Here is the point A and this will be the point B, A and B, and its value will be 2.5 ohm. And how much is the value? 5. Is it right? Now this was the final answer.